This video will be centered around programming the handle end of the Lil'Slugger bat. And to simplify this, rather than looking at the original drawing and trying to back figure all the numbers, just went ahead and redimensioned it and created a new bat handle end drawing so that we can just write this program a lot easier. So what we'll do is we will use G71 or roughing and G70 finishing to come down and face it and turn this little contour right here. And then we'll turn it all the way back, probably because you're going to be holding on to it with this area right here, because this will all be solid material still. So we'll probably turn it back to Z minus 4.3 or something. And then we'll come in with a left-handed tool and we'll sculpt out this contour using a type 2 roughing cycle. And we'll talking about that. The reason we would use a type 2 is because, as you can see, you have a directional change in X for the roughing cycle. So it'll allow you to make that change if you use a type 2 roughing, but it won't let you do it with type 1. So let's go ahead and get started here, and we'll open up a text file. So Notepad, and let's turn this on, open it up, and we'll go full screen. And I might go with just a little bit bigger format so it's easier to see, like maybe a 14. And okay, that's kind of up to you. So first thing we do when we start any program is we're going to start with a percent key with the shift 5. And then we need a program number. So letter O. I'm going to put my caps lock on for ease. And I'm just going to name this program 67895. And this will be the handle end of Lil'Slugger. Alright, so first of all we're going to start out with some safe startup lines. So if you want, you can refer to the book, which I have opened up here. It's our SL series workbook that I've sent you. And what we can do, this type 1 roughing is our first, this is going to be our first tool cycle. So if it'll let me, maybe I'll just copy this whole thing here, except for the copy, come down here to my notepad and we'll just paste it on in there. Ooh, that didn't go too well. Yeah. Wow. Okay, undo. Lil'Slugger. That's sad. I think it just didn't like the, there are no paste options. Left to right, you know, well, we'll just have to type it in. No big deal. Maybe it'll let us do this much. Copy. Enter. Paste. Yeah, boy, I sure didn't like that. So let's go ahead and just, one way we can get around this is, if you want, you can just type them in and hit enter. Probably be a good idea just to memorize everything. So let's just talk about, I'm cutting out the line numbers. Enter. And one more here. Might be easier just to type them in. Not using any line numbers until I start using my roughing and finishing cycles. So we left this N2 in here. I don't like to use tool numbers unless I have to, or line numbers. So tool 101 calls up tool 1 offset 1. This can change depending on which tool you're using and the turret position, what turret position you're using. So G50 S3000, that's our limiter. It says don't run the spindle over 3000. We're going to say G97 S450, that means RPM as opposed to surface feet per minute, and M3 is going to turn on your spindle. So we're going to use work offset position, coordinate position G54, rapid down to 3.1 and Z.1 in front of the part, and turn on the coolant. There's another one. Enter. So I think we determined our material was actually 2 inches. So if I go down here, and clearance would be X 2.1 or so. So we'll tell it, so what this is doing is wrapping it into a clearance plane so it can come down and face it. So let's just face it. Let's face the facts. So X 2.2, Z.1, and then I'm going to leave that surface feet kind of low, or leave it like that, because we don't want to have any chatter. Keep the chatter down. So if you do start experiencing chatter while you're running this part, make this number lower, like S200, and what that'll do is that'll keep your spindle RPM down. I think we had some people that had some chatter on their bats. So I'm going to go ahead and, on the safe side, I'm going to tell it G1, Z0, because there's really no reason to wrap it here, because we're, 0.1 in front of the part, and F.009. Alright, so next thing we do is we face past center, and we're going to say X minus 0.065, and we'll slow this down a little bit. I mean, I know we're not trying to get productivity here, we're just trying to get a decent baseball bat. F.005 or maybe 6. Now, first of all, we want to call out what this tool is, and I'm going to say you want to use a DNMG. And so the two tools we'll be using would be a DNMG and a VNMG. So for the turning the front, the DNMG is going to be this tool, the 55-degree diamond. And for turning the back, I would suggest that we use a VNMG, and the reason for that is because it's a 35-degree angle on this tip here. Included angle, and the problem we'll have is turning this back angle here, or this actually back radius. We don't want the back of the tool gouging into the part. I think that might be what the Mastercam problem was, but we'll see if we can't get away with it this way. Alright, back to the program. Okay. So we're going to go 6,000 per rev, feed pass, and now we're going to go to our can cycle here. Feed out to 5 thousandths in front, and feed up to a clearance plane, and that's where we turn on our can cycle. So come in here, say G0, X, and so this will move X and Z simultaneous. 2.2, Z.1, enter. So remember, we don't have to use into blocks, the machine puts that in for us. So that's kind of what I did right here. I'm just kind of copying copying this element right here. So I might see if I can't get away with just copying this one line at a time at least and putting that in there. Copy. Paste. Beautiful. So I'm going to essentially leave this all alone except for this f.012. I'm going to leave that at f.006. The book also says that any other feed rates you put in there will be ignored during this can cycle. So let's get rid of this N10. And first thing we'll do is we're going to turn on the G42. So we're, since we are cutting, it's just kind of backwards, but we're actually cutting to the right of the part, because we'll actually be cutting more from this direction if you're looking straight at the spindle. So your tool is to the right of the material, so you're using G42 here. G42, and don't hesitate to just kind of copy and paste some of these moves here, because the more you do it exactly like the example, the more likely you are to not have a non-monotonous error. So our first line paste is a G0, if you notice that. So, but we don't really want to feed to X.325. I'll make you a PDF of this. We want to actually feed up to, we want it to start at, so this is probably going to run pretty quick. I guess we could leave it 325. Remember, everything is programmed on the diameter. So if we have a, get this moved over here. We have a 1.718 dimension and a 125 radius. We have to tell it to stay 250 away from that. So I'm doubling this for the to cut that radius. So 1.718 minus 0.250. So I need to really feed up to 1.468, but I don't want to probably start that contour there. So I'm just going to feed up to like X 1.2. G0X backspace 1.2. So now if we look at our example, all we have to do is simply program the contour. We're going to feed into 0, feed up to X. So if you do these little funny moves here exactly the same way as the book shows you, you'll almost always have a good experience with it. Okay, so I think I'm going to change my game plan a little bit for this because it's going to give us problems. Okay, so next thing to do is feed into 0, and then we're just going to copy our contour after that. G1, Z0, and again, it is totally senseless to put any feed rates in this can cycle because it will only read 0.006 per rev. That's one of the limitations. So I'm going to feed up to this X 1.468, which I'm pretty sure that's what we calculated is going to be our. Let's just recalculate it one more time so we don't have any mistakes. 1.718, which is this dimension that I'm highlighting, minus 250. Enter. So that gives us 1.468, which is what I thought it was. So we're going to feed that to X 1.468. And then we're going to do a radius. And again, it's tricky because we're looking at this backwards. It's actually going to be more of a radius like right here. So it's going to be a counterclockwise radius. So it's going to be a G3. Because the bat's kind of turned around here. It makes it more difficult to more difficult to decipher which way to turn the thing. So G3, we're going to take it to the X, the 1.718. X 1.718. The Z is not dimensioned on the part, and the reason for that is because it's whatever the radius is. And since we had a 125 radius called out right here, it's Z minus 0.125. The actual radius. Z minus 0.125 and R 0.125. That'll cut that radius. Now, if you remember, G3 will stay in effect until we tell it not to be G3, so we need to tell it now G1. So we're almost actually done with this contour. And let's just figure out where we need to, because we're right here at that green dot where my arrow's pointed. That's where that leaves us. So let's just feed it all the way down here and clean out some extra material, probably down to about 4.250. Z minus 4.250. 4.250. And then it's time to kind of look at how they finish off their contour. They're actually making this part. G71, yeah. I think well, that's using two tools. It's really not that different. Come back up to here. We're just using the same tool. If you're using two tools, you take the tool home right about here, take the tool home, and then you just call up a new tool and then position it, and then call up the same thing here. So, but see, they're feeding out. And notice there's no G0 here. So we're just going to follow that exact example. G1, or just leave it in G1, and then we'll feed out to X. See, I think we'll need to put a G40 in there too. Yeah, G40. Oh, G40. Let's see, X3 point. Yeah, so it must not mind that. I feel like that will be causing a non-monotonous problem with the X move. Oh, because yes. So we won't have any problem with that either, because we are constantly moving in an X plus dimension or vector direction. So let's just X 2.0, and then we'll say G40, which turns off the tool nose compensation. And we're having to compensate for the tool nose because all these radiuses would not be correct if we weren't using tool nose compensation. So if we didn't use tool nose compensation, we would have to add into the radius to prevent it from undercutting. So if we didn't use G42, we would have to tell it R.125 plus the 32 thousandths tool nose radius for it to cut accurately. But the easier way is just to use the tool nose compensation. But remember, when you use tool nose compensation, you have to put it in the offsets on the machine, or else it will ignore it. I'm going to try to find a really good lathe setup video that will help you remember how to set those up, because I'm going to be kind of busy. I'm not going to be able to be down there a lot. So, okay, where were we? Okay, G40. We'll take it up to this G0 X 2.2. Okay. When in doubt, check the book. So that also needs to follow the end lines. I think I forgot to put my end lines in there. Since we said P10, Q20, this needs to have a, let's see, we use P11, Q24. So N11 Doesn't matter what numbers they are, they just have to match the P and Q numbers that are in the G71 callout. N24, just like that. Okay, so I'm going to check the example again. So notice we leave it here at X, because the cycle will take it back to the Z.1. We just need to wrap it back to where our start point was in X before we started our contour. So after that, we can just tell it G70. And use these same PQ numbers, P11, Q20, Q24, and then that'll go back and run the same routine except with a finish cycle. Alright, and then we just take the tool home and we'll get out our tool 2. So, let's see here. They just tell it, yeah, just turn off the surface feet and take it home. So we'll say G97. And I always like to, if you don't turn the surface feet off, the spindle will slow down really slow because it's trying to turn at whatever diameter the X is at. So you always want to turn the constant surface feet off. The G97, S300, and I'll usually turn it something low because I don't want it turning faster than it was while it was actually turning. And then G28, which will take the tool home. Okay, so now we're going to call out, so I forgot to say right hand OD DNMG. Anything. It doesn't matter what the radius is on the tool, so long as you put the correct radius into the offset page of where you put the tool offsets in. So I'm going to control save this, and I'm going to save it. You would save it to your flash drive or some, because the flash drive is where you're going to be able to transfer your data. So I'm just gonna, just to have a record of this in case you have trouble with it. This will be bat handle dot txt, and we'll put this in, let's see, open, it's got to be in the projects. Wait, oh, I'm in the wrong CNC lathe. I'm in the wrong, we're in advanced lathe. To make glasses. Programming projects. Lil'Slugger. And save. Alright. For some reason I didn't have a version of this saved as a text file. Alright, so our next tool, and again you may have to alter this depending on what turret positions are available. 202. And this is going to be a left hand VNMG. And since we're going to be sort of turning a trough here, but we're going to be doing it with this radius. So we're going to try to, we're going to leave this, and we're just going to come down to this 2.991 because we want to actually come back and turn this with a right hand OD. I kind of forgot about that. So we're going to come down to 2.991, feed up to here, cut this radius, cut up this line and over, and then straight out. So to simplify things, now that I've got kind of an example here, I'm going to save myself a whirlwind of time just by doing this Copy and paste. Oh. Paste. And voila. The problem is the geometry is wrong, and also we're going to need to use a type 2 roughing, and here's the distinguishing factor with type 2. Oh, by the way, that was on page 84 is the example I like to use for the programming. So this all should be kind of a review. So type 2 roughing is just like type 1, except when you have an x traveling in a minus n plus dimension, it needs to know that you're doing a type 2. And where the distinction is, everything's set up the same, except when this first line here, on the type 1 roughing, they just have an x value. Type 2, you have to tell it x and z, and that tells it that you're going to be compensating for the radius in 2 different directions in x. So that's a distinctive thing. So let's just go ahead and go back to our program here. So we've got, this is all good, x 2.2, z 0.1. So, but this I want to be a little bit different. I'm going to leave that at G0 and wrap it down to this 4.231. Or no, we're going to wrap it down to 2.991 because I just want to come in here and cut this out. And I might even just say 2.9 because I want these two cut. We're going to have 2 tools blending in these 2 contours. So I'm going to tell it to go z minus 2.9. Oops. Z minus 2.9. And then this can't be, we're not going to face it anymore. Let's look at our example here so we don't have any problems. Because at this point we're not facing it, we're just positioning it. But we have to give ourselves room to rapid. Notice their z.1 start position and their z.1 move here is exactly the same. So we're just going to let's just copy this a little bit here. Or G. Let's see. Yeah, let's just get rid of this. Wait a minute. Z minus 2.9. What are we doing here? Left hand, 54. Okay. Z minus 2.9. But we'll take this out because we're no longer rapiding. And we don't want this because that'd cause a pretty big crash. And so I'm looking back at the book here. So now we need to turn on our constant surface feet, and because we're rapid where we need to be. Copy. Enter. Paste. And then they have their call out with the G71. So all we have to do is give it some different line numbers. I'm going to try to keep it simple here. Say P1 and Q2. P1, Q2. Leave that space in there. And leave all that the same. Okay, so now we have to tell it two moves here. So I'm going to just tell it X 2.1 because I don't want it to really wrap out. It needs to cut that, feed into that part for us. And the VNMG actually will provide less surface resistance, and it should be not too bad. So, but let's just give it a little bit less, like D.050, and so hopefully that'll not gouge it. So let's say G42 G0X 2.1 Z. Remember, we have to give it another Z, but we don't want to do this. Let's just delete this. Backspace. Okay, Z minus 2.9. And then this will actually have to be in 1. So notice by doing this move right here, we're telling it that this is a type 2 roughing. So G1, we're going to feed to, I went ahead and went 4 places on these decimals so it wouldn't give us problems when we go to do the radius. So X 0.6929, G1, X 0.6929, and then this will let's just delete all this. And then we'll have a Z move down to, so we've got 410 and a 300,000ths radius, or 471, sorry. So to know how far to set that back, we'll say 471 minus this 300 here, or plus, which would be 771. Okay, so that's what we need to feed down to. Z minus 0.771. And so now we've got this radius thing again. So we're actually cutting this way, or think of it being the opposite way. So G2s are actually G3s. So this would be a flipped around when this would be actually a G3. Enter. G3. So how do we figure out what our radius is going to, our X is going to be? Well, you have to just calculate back from the radius. So if we're at 0.6929 right here, X 0.6929, the radius being 300, we have to make it 6 plus 0.6 because we double it for the diameter, and that's going to be X 1.2929, X 1.2929. Same thing with the Z, but we already know that it's Z minus 0.471. Thinking target dimension here. Z minus 0.471. R 0.3. We'll cut that radius. So now we need to feed up to the start of the next radius. Whoops. Which is going to be up to here. So if we got, I'm assuming these are both 125 radiuses because it didn't say otherwise. You can probably just see what that is there. Oops. Dimension. Nope. Zoom in. Come on, give me the radius. Turn the dimension off. There it is. So it's still 1.125. So we have to feed up to 1.718 minus 250. That same 1.468. G1 x 1.468. And then we'll have another radius. This looks like a G2, G3, so now that's actually going to be a, if it were turned around, it would be a G2, because think of the thing being reversed. So we've got a G2, G2. Let's see, what was that? Was that a 125? Sure it was. Yeah, so this is, wait a minute. Yeah. So we need to feed up to x 1.718. X 1.718. Z. Think about it. What are we going to do here? We're at 471 right now. So 471 minus 0.125 is Z minus 0.346. E46 R 0.125. So now we're going to feed G1 Z.1, feed off the part. The other thing I forgot to do here is this is actually a G41 because we're cutting to the right. Yeah, we're cutting to the left of the part. The part is to the left of the cutter as we're moving in a Z plus dimension, or let's see. It would be, yeah, G41. Because, let's look at our part here. When we're cutting this way, the part is to the right of the cutter. So as we're cutting this way the part, the tool is to the right of the material. Cutting this way in Z minus. We're cutting in Z plus, the tool is to the left of the material. So that's the difference between G41 and G42. Same thing applies to boring. It's all about which side of the part the tool's on. Okay, so we are done with that. Let's see how they turn it off. Pretty much the same. They got a Z move there. And we're just going to feed back to the block number of the PQ part definition, which is X2.1 right here. Same number. Think of bookends. Now let's see. G1, and so did they turn the comps off there? Yeah, see, they don't. Hey, wait a minute. Where'd they turn the comps on and off? There's got to be comps. Roughing tool. G50, G54, G96. I think they just must have screwed up and left them out. So right here you've got type 2 geometry. Change next. Yeah, G42. They must have just left that out. That's weird. Yeah, I've not noticed that before. Maybe I did, but I just forgot. But we definitely need to turn the comps off here. Which we did. G40, G0, X2.2, which is right where we started. And so we should be good there. Bear with me, we got one more tool path, and then that'll be the end of the bat. Just scroll up a little bit here. So we're going to call up tool 101 again, and we're just going to do a simple type 1 cycle that's going to come down, position itself here, and maybe we'll go G type 2, and that way we can feed into the part and just cut that radius. So when you set your part up, you got to make sure you look at where your deepest Z is. That's how much has got to be hanging out in front of the bat. Also, you're going to have some extra material out front here. You need to make sure your Z0 on your part is where you've measured your bat, and you know how much has to come off the overall length. That needs to be your Z0. That's pretty important. The height, check it with a height gauge, and write on there with a pencil or something how much you have to take off. And when you set your part off, touch off your tools, add that into the Z minus, because that's going to be your Z0. Alright, so we'll go with a type 2 again. I'm going to go back to our right hand DNMG. So that's going to be T101. Right hand DNMG. Alright. Part of me thinks we should probably rough some of this out with a parting tool. It should be fine. What happens though is, as you're roughing in with those OD turn tools, it starts really getting buried. But here's the thing: if we've got strategize, you have to strategize this every time. 1.718 minus, which is this dimension here, minus 0.629 or 692.9. 692.9. So that's 1.025 on the diameter divided by 2. You're really only feeding in about a ½ inch here, so I don't expect to have a whole lot of tool burial. You know what I'm talking about, where the back side of the tool tends to kind of bury into the part. Let's see, how far do we turn this back? We might want to turn this back a little bit farther, yeah, like a whole inch. In fact, let's rethink that. So 4.2431 minus, which is this dimension, minus 2.9916. So that will give you enough room for your tool holder, being 1 inch. I don't think that would be any problem at all, just to turn it all the way back to that when we have our OD right hand tool out the first time. So let's just change that to Z minus 4.231. Go back up here to our very first tool, and there it is. Z minus 4.250. Maybe I already did that. I did. I already did it. So we don't have to worry about it. There should be clearance there, and then you'll just be cutting out a ½ inch. Alright, back to the drawing board here. And I'll just kind of, since we're doing a type 2 repeat, I'm just going to copy this and paste it there. So that's going to be about as long as our program is. So I'm just going to go ahead and say M30 here, which is program end and rewind, and we'll just stick a % key in there, or else the machine won't see it. So we're going in there, 2.2, Z.1, no problem. Z minus 2.9, all this is good. At 410, let's make that more like 200, and just to keep the the chatter down. And let's do the same thing up here. S200. Okay, S200. And we said that twice now. Delete. Backspace. We do that up here too? We did. Why did we do that for? Who knows? That's the bad thing about copying and pasting. You have to repeat your mistakes. Alright, so I like all this. X2.1. And so this Z is not right. Look at the... It's going to be a little easier if you have this printed off in front of you instead of switching back and forth. Here's where we want to start. We want to start at Z minus 2.9, which might actually be right where we want to be, or where we were. Z minus 2.9, perfect. So that's all set up for us. So we're going to just feed right into there. And we're going to feed down, feed down to Z minus 2.9916 instead of 71, minus 2.9916. And better control save this puppy. I'm not going to send you this program because I want you to actually write it. Oh, I didn't notice it did that. So this is since we're backwards, this G2 cutting, or actually G3 is actually G2 because we'll turn it around. So G2 X point 8899. Let's just delete all this. And this. G2 X point 8899, pretty easy to remember. Z minus, again I went to fourth place decimals here just so we wouldn't have any trouble. 4.2431. 4.2431 R.8. Now when we're programming radiuses like this, your R values always have to be plus, because remember R minus means over 180 degrees, and we're not doing any of that. So I think we can just go ahead and feed up to our safe spot, which is going to be this X 1.718, because remember we've already turned that down. So let's go 1.750 for little extra safety. G1, don't forget G1, X 0.750, or is it 1.750? I feel like I did that before. 1.750. I better double check I didn't do that on some other ones. So that's pretty easy. We'll say, remember, we got to make sure these P's and Q's line up with the P's and Q numbers here. N1, N2, P1, Q2. And we'll make this N1 and make sure this is N2. Delete. And G28, that should cut it. Let's make sure we didn't do any. So if I go Control F, I'll look for any kind of X 0.750s in there. Cannot find it, so that's good. So before we say, hey, this is a great program, let's Control save it, and let's just review what we got going here. So I'm going to start up here, And we're going to say tool 101, G50S3000, turn on the RPM at 450. I'm not so concerned about exact numbers, but I would be looking for anything that is obviously wrong. So as I'm going through this, I'm drawing a picture with my finger. I'm drawing the contour. So I'm going to wrap it down to 2.2s, plus I'm programming this thing backwards, so with the part turned around. So we'll say G0 x 2.2 Z.1, turn on the constant surface feed at 200 surface feet per minute, feed into 0 at 9 thousandths per rev, feed down to minus 0.065, and X at 6 thousandths per rev, wrap it out, and then we start our G71 cycle, leaving 10 and 5 on Z. I think with this one, we got enough rigidity, we can probably get away with it, but I'm going to make that 0.065. Okay, so G42, G0 x 1.2, which is, or it should be actually 2 points. This is why you do this. G1, Z0 x 1.468, G3, which is counterclockwise, x 1.718, Z minus 0.125, R 0.125, and you can always debug your own programs, because there's no guarantee this is going to run for you. So G1, Z minus 4.250, X 2.0, and I might actually make that 2.050, so we're definitely off the part. And then P11, Q24, and 11 and 24 definitely jive. 11 and 24. Okay, looks good enough. So we got a G50 S3000 limiter till 202, G97 S450 M3 turns on the RPM at 450 RPM, wrap it down to 2.2 Z.1, and we'll constant surface feed on at 200 feet per minute, and we're going to rapid now, still down to 2.9, and turn on our type 2 roughing, because why? Because we use X 2.1 and Z minus 2.9, which is the exact same value as where it's at, but that is how the example in the book worked out. Using G41 because we're turning in a Z plus vector, and the tool is to the materials to the left of the tool. I'm sorry, the tool is to the left of the material. I guess it all depends on how you look at it. But it is G41, and we're going to feed down to Z minus 7. Start back here. Yes, X 0.6929, Z minus 0.771, which is feeding plus. And then we got a G3, which is true. With the R 0.3, we're feeding up to 1.468. Then we got a G2, which is also true. True in blue G2. And with the R, G1, Z.1 feeding off the part. And that is actually a letter O. Gotta watch out for those, because that will definitely control save. And then we got the G70, which will come back, and that's a good time to check out your P and Q numbers, which I actually have wrong. We used P1 and Q2 down here, and we used P11 and Q24 up here. So let's use P3 and P4. Space P4. And then we have to change our N numbers, if you remember right. 1 and 3 and 24. I'll just delete the 4. Okay, so that should all work. Okay, so X 2.1 feeding down and out. Got a G3, and I'm moving with my finger, you just can't see it. Moving my finger with the contour, 71.3, feeding up to 1.468, and then we got a G2, and feeding off the part, rapiding out to our start dimension, which is going to be the X2.2. They have to be the same. And then this P and Q don't jive. P3, Q4. Q4. And then we're going to turn on our constant surface feet. Control save. And then we come back out with our right hand D and MG. And we are now back to G42. Didn't catch that on the way through. It's always important to go back and proofread your work. So we're cutting in a OD Z minus direction. Just cutting this little scoop here. Okay, we're turning on. You don't have to really do this every time. It's only there because I'm copying and pasting. Once you set the limit, it'll stay there through the whole program. Some people like to set them every time. I'm kind of a minimalist, but it all depends on your company's policy. If they have one, of course, follow it. So 2.2 Z.1, rapid down to 2.9, G96. Oh, let's see, forgot our S. 200. And we got a G71, P1, Q2. Do we use P1 and Q2 somewhere else? I don't think so. It's a pretty short program for the 45 minutes or so it's been taking to write this. So P1, Q2. Starting to get googly-eyed. Yeah, we got 3, 4, 11, and 24. So your P and Q numbers have to jive, or it'll throw out a non-monotonous code. Or worse yet, if you put P3 and P4 here, it'll go back and try to do this P3 and P4. It will do it. So always watch for random dotted lines and rapid moves that don't seem to look right when you're running the graphics. So we're going to wrap it down to X2.1, Z minus 2.9, so we're definitely into the part. Feeding G1 at 0.006, Z minus 2.991, which is feeding right to the edge of that radius, and then we do our G2, which this is actually, yeah, that's a G2, and that's our target dimension. Now these values here, X is still on the diameter and Z is not, but since it's not a perfect 90-degree radius, like this here, this radius is a perfect 90-degree radius. In other words, it ends in 90-degree quadrants. So that's how you configure, you know, the Z being 125 this way and the X being 250. But with these types of radiuses, you can't do that. You have to have it actually go by the actual dimension. That's why I just include them. It's almost impossible to trig out. So that one was, yeah, anyway. So we're feeding up to X1.750, which should be out of the part because of the fact that this is, whoa, X1.718. Should be well off the part because we cut back that far, 4.250. And wrap it out, and that should do it. I'm going to control save this, and hopefully you'll have good luck with writing this program, loading it in, and running it. So the next video will be most likely the y-axis video.